Okay, class, it's a snowy Monday, so let's work on setting up some of these homework problems. I've had a couple of questions about problem 2, the tank draining example. So let me just put in that we know that the mass initially in the tank is 2,500 kilograms. We saw that in the last problem setup. We know that the initial height of liquid in the tank is 12.5 meters. And we're asked to find if the mass flow rate exiting is equal to the square root of 2gz to find the time required to empty this tank. So let's look at our conservation of mass equation in its most general form. The time rated change of mass contained in that tank is going to be equal to a negative m dot e. There is no m dot I coming in. So we've got dm dt is equal to negative square root of 2gz. And some of you have rightly recognized that the right-hand side and left-hand side can both be written as a function of z, and you need to be careful on the integration. So let me help you guys set this up. The mass is simply equal to the density of the liquid in the tank times the volume occupied by the liquid. The volume occupied by the liquid can be written as the constant cross-sectional area A times the liquid height Z. So assuming that rho and A are constants, which they are, we get rho times A is equal to dm dt, or excuse me, dz dt in this case, is equal to the negative 2gz, the 1/2. All these should be square roots, guys. All right, so dividing both sides by rho A, we simply end up with dz dt is equal to negative the square root of 2gz divided by rho A. Now the mass flow rate units here are kilograms per minute. When I look at the density times the cross-sectional area, this is going to be kilograms per meter cubed times meter squared. So we're going to get kilograms per meter divided by kilograms per meter. And so what we'll end up here with is the units of meters per minute when we look at dz dt. So the units work out okay. We just have to figure out how to separate and integrate this effectively to get dz on one side and dt on the other. So let me try to separate and integrate those real quick. dz over z to the 1/2 is equal to negative, and this is all a constant coming out front, so the square root of 2g divided by rho a dt. And now all we have to do is set up our integration limits from 12.5 down to 0, and here from 0 to t. But all this is a constant, so you just get the integral of dt is just t minus 0 here on the right-hand side. Thank you.